Hi, Pathos students, and welcome to this discussion of acid-base balance. Now, acid-base balance can be a little bit tedious as we're learning all the steps. So pay close attention, take good notes, and we'll do some practice problems at the end. So the body's pH is regulated within a very tight range between 7.35 and 7.45. And this is a number that you will want to memorize. pH is a reflection of hydrogen ion concentration. And you'll also want to remember how the pH moves in relationship to the number of hydrogen ions. And I hope this is a review for you. But as we have an increase in hydrogen, we will have a decrease in pH. And as hydrogen in the blood decreases, then the pH will increase. Hanging on to more hydrogen makes our blood more acidic, and having less hydrogen makes our blood more basic or more alkaline. And again, we need to keep it within those really close parameters, because if we shift below 6.9 or above 7.8, that is not compatible with life. Body acids result from volatile acids. And metabolic processes produce these acids. And volatile simply means that they are gases that we are able to eliminate through the respiratory system. In addition, metabolism also produces non-volatile substances. And these substances we either have to buffer with other chemicals in the blood to neutralize them, or we have to eliminate these acids via the kidneys. In this figure, you can see how digestion, absorption, and cellular metabolism of food result in the production of hydrogen, carbon dioxide, and phosphate chloride. Our blood buffers provide the chemicals that we need to take on some hydrogen ions, as well as some chemicals that are acidic and can help to buffer the alkaline substances. Carbon dioxide is an acid, and when dissolved in water, and when we think of pH, carbon dioxide is the primary acid component, while bicarbonate is the primary alkaline component. When we exhale, we eliminate some CO2, meaning we're actually blowing off acid. However, only about 10% of our excess body acids leave through the lungs. Blood buffers in the kidneys are responsible for excreting the rest. The respiratory mechanism of correcting pH by blowing off CO2 happens fairly quickly, within minutes, while corrections from the kidneys could take hours or even days. This chemical equation shows you the interchange between carbonic acid, hydrogen, and bicarbonate. The goal is to achieve a balance between carbonic acid and bicarb. When CO2 is increased, then the chemical reaction is pushed to the right, meaning more hydrogen ions will be formed, and that will result in a lower pH. Conversely, with an increase in bicarb, the chemical equation will be pushed to the left, resulting in fewer free hydrogen ions and a higher pH. As a nurse, you'll be tasked with evaluating these lab values. The provider will order arterial blood gases, or ABGs. Notice these values come from arterial blood samples, not venous blood. Venous blood is typical for most serum lab values, but to get the CO2, bicarbonate, and pH, you have to have an arterial blood sample. So the slide shows you a sample of an ABG result. Based on this information, you will soon be able to determine the cause of an acid-base imbalance. And then in later courses, you're going to learn how acid-base imbalances are corrected. As you're interpreting an ABG, the first number to consider is the pH. Does the pH tend to fall around 7.35 or lower, or at least below 7.4, if you think about 7.4 being the absolute midpoint? Anything that tends to fall below 7.4 is considered acidotic, and anything that tends to fall above 7.45, we're going to think, or 7.45, we'll think about it being in a more alkalotic state. If you're dealing with an acidosis, it could have more of a respiratory component, or it could have more of a metabolic component. If patients aren't moving air effectively, then we would see a retention of carbon dioxide and an increase in acid secondary to that. So respiratory acidosis result from oversedation, maybe people who have CNS disorders where your brain is not telling your body to breathe, or even a neuromuscular disorder where your diaphragm is not functioning appropriately. Metabolic acidoses can result from loss of bicarb or bicarbonate through severe diarrhea, more acid production from breakdown of fat. This happens when people are on high ketone diets. It happens when people are in diabetic ketoacidosis, which we'll talk about more in our metabolic chapter. Or it happens if you've overexerted yourself and built up lactic acid in your muscles and have gone into anaerobic metabolism. Also can happen if your kidneys are not working correctly and you can't secrete hydrogen, or it can happen with a number of electrolyte imbalances, but probably the most common would be an increase in chloride. So you might have a pH greater than 7.45, which would indicate an alkalotic situation, and this can happen with hyperventilation, blowing off too much CO2. So if we're blowing off too much acid, then we'll have an alkalotic situation. Alkalosis can also result from taking in or eating too much bicarbonate. The most common reason for that would be an antacid that contains bicarbonate. Or if we're trying to correct an acidosis and we give people bicarb in the IV route, it's very easy to overcorrect. So we could start with an acidosis and result in an alkalosis if we give too much bicarb. We can put down tubes and take out stomach secretions. So if we lose stomach acid from the stomach through suction or from vomiting, then we can have a metabolic alkalosis. Also, kidney problems can cause us to retain bicarb. So we could end up with an alkalosis with kidney problems also. We know that pH imbalances can be related to the respiratory system, or they may be metabolic. If we're dealing with a respiratory acidosis, we're going to see a higher CO2, an increase in this number. This would increase the formation of carbonic acid and have more hydrogen ions. Remember, more hydrogen ions means a lower pH, and usually we'll see the metabolic system attempting to compensate by holding on to more bicarb. In respiratory alkalosis, the PCO2 would be decreased, the reaction would go to the left, and we would have fewer bicarbonate or hydrogen ions. Higher pH, and consequently, in an attempt to compensate, we would also see a decrease in the bicarbonate. If we're dealing with a metabolic acidosis, we'll see a lower pH, lower bicarbonate. Respiratory rate and depth would usually increase because the respiratory system is trying to help out by blowing off PCO2. In metabolic alkalosis, the pH and the bicarbonate levels would be higher. In this situation, respiratory rate and depth would be decreased or hypoventilation in an attempt to hold on to more acid or more CO2. We're going to look at some ABGs now, and we're going to first try to determine the primary mechanism, what's causing the change, and the ABG diagnosis will include 3 terms. The primary system causing the change is in either respiratory or metabolic. The degree of the pH abnormality, is it alkalosis or acidosis? And then finally, we'll talk about the compensatory mechanism. Fully compensated, I apologize, means that the pH has returned to normal range. And in that situation, both the system that caused the problem and the compensatory system will be abnormal. Partial compensation means that the causative system and the compensating system are abnormal, but the pH is not quite normal yet. And uncompensated means the pH is abnormal, the causative system is abnormal, and we're not seeing any there's no changes in the compensating system, so it doesn't seem to be responding. That number remains normal. So let's work one of these problems together. The blue part of this table actually represents your tic-tac-toe board. So if you just think about these lines, this line, and this line, and here, you could draw your own tic-tac-toe board right now. And then I labeled these acid, normal, and base, and the 3 components that we're going to look at is pH, PCO2, and bicarb. And you're going to place these components in the chart, and then the row that has 3 in a row is the winner, or at least 2 in a row, I should say. So to show you how this works, the pH for this problem, the patient's pH is 7.47, the CO2 is 28, and the bicarb is 18. So on the pH line, 7.47, we're going to write that number under the base and alkalotic column. The CO2 is 28. So let's look at 28 in relationship to the normal. So it is low normal. A PCO2 that is lower than normal is actually falling on the alkalotic side. So we're going to write the pH, or the CO2, 28, right here. And then lastly, the bicarbonate is 18. Normal bicarb is 22 to 26. 18 is low. So 18 actually goes under the acid column. It is relatively more acidic than it should be. So what we have here is a respiratory alkalosis, and we call it that because the pH matches with the respiratory component, and the acid part, the metabolic component or the bicarb is attempting to compensate, but our pH is still abnormal. So we're going to call it respiratory alkalosis partially compensated. So here's another one. The pH is 7.48. And again, that's a base or an alkalotic pH. So we're going to write 7.48 here. The CO2 is 48. Now 48 is higher than what would be expected. So that's more acidic. More CO2 is more acidic. So we're going to write that in the acid column. So in this column, I want you to write 48. And then the bicarb is 29. So we can see that 29 is higher than the normal range. So we're going to write 29 right here. So this is metabolic alkalosis because it's an alkalotic pH, and because the respiratory component has started to shift, we're going to call it partially compensated. And in our final example, we have a pH of 7.35. So again, this is acidic, but it's actually in the normal range, but is on the acidic side. So you can write your 7.35 in this column, but I would make an arrow toward acidic to remind you that it is on the acidic side of normal. Now look at the CO2. It's 50. So we know normal CO2 is 35 to 45. So this is too much acid. So it's a high number, even more acid than we would expect. So we're going to write it in the second row. So we'll write 50 here. The bicarb is 30, and 30 is actually more basic, more alkaline than normal. So we're going to write our 30 here. So what we have here is respiratory acidosis, and it is fully compensated because our pH is actually in the normal range. And that concludes this discussion of pH.